Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching along on YouTube and you're watching live, feel free to use the live chat. If you're watching after the fact, just feel free to leave a comment, and I'll get to those as I can. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 11 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic. Then before I did that, it was 8 years at Subaru. So working in a dealership, and over time, I guess, just became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is air conditioning testing and diagnosis. And if you're watching this at the time that we are broadcasting it, the last week of May in 2024, it is starting to get warm out there. It may be very warm where you are, depending on where you're at. But I know I'm up in the Northeast, and it's, we've had good 80-degree weather for a while, and we need that AC to work. So it's always timely in the mid to late spring to kind of freshen up and refresh our knowledge on air conditioning, because we might not be doing it in the middle of December or January. Maybe we will, but it depends on where you live, I suppose. But we're going to talk about all the different components that have to deal with the air conditioning and HVAC, as it were, all together. So we have inside the car, and we really have outside the car in the engine bay. So we'll separate it into two different spots here. So first off, we'll talk about the exterior components. So that's the stuff out in the engine bay. So things like the compressor, which includes the clutch, the oil, refrigerant, the evaporator, which I guess is technically inside, but it's kind of part of that outside piece. The condenser, the receiver dryer, expansion valve, and pressure switches, and any other electronics that might be related. So when it comes to the compressor, the majority of them are belt driven. Hybrid and EV compressors are going to be electric. They're going to be running at maybe about a 300, 400 volt high voltage. Oftentimes they're AC in that case, as well. AC as an alternating current, not air conditioner. Belt driven is going to use an electromagnetic clutch. The clutch can then be tested with a scanner or component testing. I can do a bidirectional control to turn it on and off. And I can also test it to make sure voltage and ground are applied and all that. It can either be a fixed or a variable displacement. So variable displacement also may not have a clutch that they use. So they might not need it. If a variable displacement, you can basically turn it all the way off with the variableness of it. So here's the compressor, and it's just kind of a side view here. We got the clutch assembly on the front. We've got this wobble plate with the pistons attached. And as the pistons go around and cycle, using that wobble plate, it's going to push those pistons in and out. And then the pistons, of course, in turn, press down on the refrigerant that's in there and causes it to increase pressure. So we got charging ports, intake and discharge valves. The cylinder head here is on the back. And then we can see the different pistons and the connecting rods and everything. It's kind of like a small engine, if you think about it that way, because what's an engine is really just an air pump, right? So in that way, but there's no combustion involved, right? We're just compressing things to increase the pressure of the refrigerant. So here is a example of a swash plate compressor. So you can see how the pistons go back and forth there, and they're going to compress, and it's just riding on this plate that is on an angle, and it just kind of pushes them around, and they ride back and forth. So that's a more traditional style swash plate compressor. We've had those for a while. And then we can see it's a little bit variable too, because we see it's not pumping as much now. So it's variable. Let's go back to the beginning. You can see how they're pumping a considerable amount right there, back and forth, a lot of travel with those pistons. And then as it goes to about the halfway point in the video, you'll see it gets smaller and smaller as it changes the angle of that plate. Now they're getting, travel's getting smaller and smaller there. So that is a variable swash plate on that. Also a wobble plate compressor, which does pretty much the same thing, except the plate itself is, you can see cut on an angle, so that one's not variable. So it just kind of spins around. We get the low pressure coming in. We got some check balls in here that allow the low pressure in, and then it turns to high pressure, which then overcomes the spring pressure, and then it's able to go out that way as well. Now with a variable displacement compressor, the wobble plate on there the angle can change depending on this little arm up here. So the arm can change the angle of the plate, which changes the travel of the piston. The more travel I have, of course, it can compress a lot more. The less travel I have, it won't compress as much. So it can change the angle, minimum angle, maximum angle, and then you'll see it's going to change the amount of pressure. And there's a control valve in here that controls the back and forth here. You can see how it pushes on this piston here, and it changes the displacement of that. So a variable displacement can be essentially turned off by making it flat so the pistons don't move at all. Like I said, sometimes it doesn't use a clutch depending on this. And then we have the electric compressor, which is going to be used on, like I said, hybrids and EVs, just because it's more efficient than running it off the engine if it has an engine in a hybrid. And of course, in an EV, it wouldn't have an engine at all. So it has to have a way to spin it. So it's just going to run a DC motor, which runs a scroll compressor on this side. And then refrigerant comes in, gets compressed in the scroll compressor, and then it comes out at high pressure on the other end. So those are three basic types of compressors. Now, as far as refrigerant types, we've heard a lot about these over the years. We got R12, which would be your older style, pre-1994. Then they made the big change in 1994 to R134A because it was better for the ozone layer and all that stuff. So they used that for a while. Then they come to find out that's not all that great either. So they came out with the replacement for that, which is R1234YF, which is 2012 to pretty much current vehicles. And then some way outliers, mainly in the European market, they tried using this R744, which is a different type of refrigerant, but they had some problems with that as well. So they just decided to stop using it and went back to the 1234YF that's out there now. Now, talking to some people in the air conditioning space of the industry, I know they're working on other refrigerant replacements because the one issue with 1234YF is it's fairly flammable. And that's not the best thing in the world. So we want to be sure to not have a flammable or as much of a flammable substance on the vehicle if we can at all help it. So we have different types of refrigerant, which means we have different types of compressors, which means we have different type of oil. So in this case, this is our, we're only going to go back to 134A because it's been quite a while, been 30 years. R134A belt-driven compressors, vast majority of the market still, 1234YF, of course, is creeping in, but that uses a PAG oil and R134A. And then we have electrically driven compressors. Toyota switched that in 2010, and of course, the majority of them use that now. So that's still an R134A, but it uses a different type of oil. We want to use a non-conductive oil if we can in there. So the oils can't mix. It'll be the same refrigerant, but we don't want the oils to mix. Then we have 1234YF on belt-driven compressors. It was first introduced in the States in the 13 Cadillac. And more than half of the 17 and newer models is pretty much just about anything that's out there nowadays is going to have that 1234YF in it. And it uses a different type of oil once again. And then on 1234YF electrically driven compressors, you're going to have it's the same type of oil, but it's going to be 1234YF, but it's a different type of oil than you would have over here on the 1234YF. So we don't want refrigerant contamination between the two types of refrigerant, just like R12 and 134A, you didn't want to have that mixed. In this case, you also don't want to mix 134 and 1234. And then we don't want to have any oil contamination between the hybrid and the non-hybrid vehicles as well, because they don't really mix either. So in theory, it looks like we probably need like 4 different machines, but there are ways to inject oil where you don't have to necessarily use it with the machine. You can just have one of those oil injectors. So because of this, there are multiple different types of machines on the market. And of course, Snap-on has some as well. So we do have a specific one for hybrid vehicles. We have a dual 134 and R1234YF machine that runs both refrigerants and both oils, but not the hybrid. And then we have 134 only, of course, and 1234YF. So maybe you have a few different machines in the shop. Maybe you have a combo machine in the shop. However you need to do it, you just need to be sure that you put the right refrigerant in, the right oil in, and the right amount. Because especially on these 1234YF vehicles, they can and usually are critical charge systems. So they need to be a set amount. Whatever the manufacturer says it needs to be, you need to make sure that set amount is correct. And how do I know what it uses? Well, the best place to look is under the hood on the sticker, because it could be even, here's 1 year difference. So we got a 2016 Focus with a 2-liter. And in that case, it says it took 4.9 ounces of oil and 1.3 pounds of refrigerant, and it is 134A. And it's a different PAG oil. On the refrigerant in the 1234YF on the 2017 at 1.37 pounds. So it takes slightly more 1234YF and slightly less compressor oil in there. And you'll notice that it's a different oil spec on there. So make sure you're reading those stickers underneath the hood. Now, actually, this is this next slide is kind of a recent addition as of this afternoon, because I had somebody on Facebook ask me a question. It's like, hey, I'm having a hard time finding charts for pressure versus ambient temperature. I couldn't really find one that had humidity and outlet temperatures as well. If you go to and check out MACS, M-A-C-S, that's the mobile air conditioning folks that are kind of in charge of all the specs and everything. They have a nice PDF that you can download that has the temperature versus outlet temperature, chart like this. And I was able to find this one online as well. So you see, they're fairly close. So if I look at R134A pressure on the gauge at, say, 80 degrees, which it is right now in my house, 40 to 50 PSI on 134A, 43 to 48 PSI on 1234. So it's a little bit closer of a window, but it's pretty close. And then on the high side, 175 to 210, 173 to 205, right? We're within it like 1% or 2% as far as the pressures are concerned. So your rule of thumb on 134A is probably not going to go entirely out the window with the 1234YF. It's going to be fairly close. But if you want to be really, really accurate with it, you can find those charts online. And then, of course, with that chart, what does it mean? So if they're both in range, you're good. If they're both low, probably needs refrigerant. Maybe it has a leak. We don't really go on leak detection in this particular class, but maybe there is a leak somehow and you might need to add refrigerant. If the low side's low and the high side's high, then possibly blockage of the expansion valve or orifice tube, depending on what it uses. Low side's high, higher side's low, needs service, possibly a faulty compressor. And then if both sides are high, it's overcharged. Slowly remove the refrigerant with the machine. Don't just go pressing on the little Schrader valve that's in there and venting to the atmosphere. That's bad. We don't want that. So don't do that. So slowly remove it using the vacuum function of your AC machine, right? I'm gonna draw it down a little. Maybe you just do a full vac and recharge to the proper setting. Especially with those critical charge vehicles, like I mentioned earlier, they can be a little finicky if they're not exactly where they need to be or within a percentage point of where they need to be as far as the refrigerant. So definitely make sure you have the 100% correct amount of refrigerant in there. All right, now let's go to the other components here. So we got the evaporator in there, and that's going to be in the passenger compartment, and that can be a place where I can have an issue as well. If you think about a customer comes in and they say my AC is not working. Could be a lot of things. Could be a blockage, could be a refrigerant problem like we just talked about for the last 5 minutes or so, could be a compressor problem, could be an internal problem inside the actual vent system. Maybe their mode door is stuck to heat. I saw that so many times in the shop back at Subaru when we had the old manual days. Maybe not so much in the automatic days. Well, yeah, I suppose you could have a bad actuator. But in the manual days, for sure, that cable falls off and you take a hard left turn, mode door is going to flip all the way over to the hot side and say, oh, my heater blows hot when I turn left and it blows cold when I turn right. There you know it's a mode door problem, right? So you gotta ask the customer in your interview, you know, what are the problems you're actually having? Is it only blowing cold sometimes? Is it never blowing cold? You know, what's the problem? Then you can address it from there. You know, hook up your gauges and see about the refrigerant, but also you can test the internal systems, which we'll talk about here in a little bit. So the evaporator is the part that's in the passenger compartment. That's the part that makes the air blow cold. So the warm interior air is going to blow over the fins. It's going to remove the heat from the air. And then as that happens, the liquid that's in there, because it's going to be in a liquid state at that point, it's going to turn to a vapor. It's going to evaporate and vapor up. And usually in the heater box near the heater core is where that's going to be. The condenser is going to be in the engine compartment. And as ambient air and the fan cools the refrigerant, because I'm going to have hot refrigerant going through the condenser, it's going to condense it back down to a liquid. So what they do is in the name, makes it a little easier to remember. Right? So my compressor is going to be, or my condenser is going to condense it back down into a liquid, and my evaporator is going to evaporate the liquid into a gaseous state. And then the compressor is going to move it back. The receiver dryer is going to filter the refrigerant. There's also a desiccant in there that is going to remove any water that may be in the system. Hopefully there's no water in the system, because if we pull it down with a vacuum, it should boil off all the water and we won't have it. But anytime anything in the system is open to the atmosphere, we can definitely introduce ambient water liquid into there, and it's definitely not going to work nearly as good as it should if we have water in there, because you know, it's not going to be able to compress the water to the same rate as the refrigerant. So it can change the performance of the system. So the receiver dryer should be changed anytime the system's open. You should just put a new one. Expansion valve is going to step down pressure before it enters the evaporator. So we're going to have high pressure coming in, and we need to be able to step it down a little bit. Most 134A and 1234YF vehicles, they are going to use this style expansion valve. And the outlet pressure is going to help regulate the intake pressure. So we have this sensing element in there. It's going to notice where the pressure is. Here's a high pressure liquid coming from the receiver dryer, goes to the evaporator as a low pressure liquid through this metering. And then out of the evaporator, we're going to have a low pressure vapor. So the compressor has a low pressure vapor, and the outlet pressure is going to help regulate the inlet pressure due to this needle valve. Now, this can be a common failure point. Like I said, when I worked at Subaru, we'd replace these all the time because they'd either leak or they'd get clogged up or the needle valve didn't quite work right. So can be a common failure point depending on the manufacturer. Then we have pressure switches as well. So they can be on or off dependent on pressure. And we can also have separate high, low, and medium switches, and it can also be a combination switch, which high and low in it as well. So the refrigerant pressure is going to push down on a little diaphragm, which will activate the contact, close the contacts. So in this case, we have power going up, and then when it closes with the pressure gets high enough, it's going to close on this, and then it goes out to the compressor clutch. In this instance, always check your wiring diagram. But in this particular instance, that's what grounds the clutch or provides power to the clutch. And then that allows it to turn on. So it just kind of depends on whether it's high, low, or other. Now let's talk about the interior of the vehicle. So these are going to be things like the inside and outside temperature sensors, the sun load sensor, the blower motor controller, actuators such as the mode door, the blend door, and the recirc door. So a lot of moving pieces parts inside the vehicle. So this is a Ford Explorer. It's got rear AC as well. So I got rear vents, rear blower, front vents. Plus the foot vents and all the piping, etc., that goes to the back for the rear evaporator as well. So a lot of different components to fail. Like I said, always double check with your customer. It might not necessarily be an AC or refrigerant. It could be a whole host of other things that are not a refrigerant. And if we see, they all kind of play with each other. We got the HVAC control module here. We got the actuators, a bunch of actuators there. Blower motor controller controls that. Also feeds things like gateway module, pressure transducers go to the PCM, clutch relays, variable displacement compressor, sun load sensors feed it, in-vehicle temperature and humidity sensor, evaporator temperature sensor. So there's a lot of failure points in a modern air conditioning system that are not the refrigerant, the compressor, or a leak. So we could have an electrical failure as well. So just always make sure you're asking questions to suss out what the issue is. So the sun load sensor. Sun load sensor, especially on automatic AC systems, it would need to know that the module would need to know how much sun is coming into the compartment, so I know how quickly I need to cool it down. If I got the sun blaring down at a 100-degree day, it's going to operate in a different mode than it would if it was 70 degrees on. I'm just trying to get it down to 65. Converts solar radiation into voltage, kind of like a solar panel and a teeny tiny little solar panel, but it's a photodiode. The control module uses this as an input, like I said, to understand how much sun is coming into the passenger compartment. Ambient air temperature is going to be on the outside of the vehicle. Usually it's mounted behind the bumper. It's a thermistor. It's going to convert ambient air temperature to a voltage, which is then read by the control module, which uses it as an input. Usually it's in the front bumper, but usually it's not open to the atmosphere, so we don't get cooling effect from driving down the road. It's usually behind a piece of the bumper, so it can just kind of get ambient air around it in a bubble. We also have the cabin air temp sensor that'll be inside, and it's going to work very similarly to the outside sensor. It's a thermistor, and it's going to convert in-car air temperature to a voltage. So it knows, okay, I need to get the cabin down to 65 degrees, and I'm reading 80 degrees going across it. I know I need to cool it more. So the control module is going to use that as an input. Usually it's roughly in the center of the dash. Maybe it's a little bit on the driver's side. It's going to be closer to the people who are normally going to be in the car the most. So they usually just put it kind of towards the front. You might see a little grate on the dash, and it'll be behind that. See it. And usually it's got a little hose that goes back. There's just another look at it inside. We got the little thermistor in there. Also, some vehicles use an air duct temperature sensor as well, so it knows the performance of the air coming out of the duct. It's going to convert that air duct temperature to a voltage. Once again, as a thermistor, just like the others. Control module will use this as an input, and usually it's in the air duct itself, fairly close to the vents. Maybe it's a few inches in, but it's going to measure that temperature coming out to check the performance of how is it working. Is it working cool enough? Also, some vehicles use a windshield temperature / humidity sensor / whatever other sensor. Combines temperature and humidity sensors. Is going to measure the windshield temp, cabin humidity, and the humidity sensor temperature itself, the temperature of the actual sensor itself. Control module is going to use that as an input, and on vehicles that use it, it's going to be mounted to the upper windshield. Some actuators as well. Like I said, an actuator can fail easily. So a mode door actuator. Going to move it back and forth, or the blend door, or what have you, recirculation door. It's a reversible electric motor. It's going to have plastic gear reduction gears in there usually. Contains a position sensor often, so it knows where in space it is. And it's going to operate linkages for, like I said, recirc door, blend door, or doors, mode door. And it's going to be something like this. They're usually mounted on the outside of the air box. So there's a mode door actuator there, and there's the air mix door actuator, which is going to go from hot to cold. And that brings me to this dollar store animation that I've made for you. So this is a basic HVAC system, vent system inside a vehicle. So we got the defrost goes up to the windshield, dash goes to your face, floor goes to the floor. Got the heater core in there, we got the evaporator in there, and we got the blower motor in there. And we have outside air from the outside vent. It's going to go through the cabin filter first, then it goes in. Or if it's on recirc, it's going to have cabin air coming in. So in this case, we're on recirc. It's going to pull in the cabin air, and it's going to go out to where it needs to go. Now, if we move it to outside air, it's going to just change that recirc door from recirc to not recirc, and it's just going to pull it from the outside. The blend door, it's going to change the temperature. So by default, it goes over the evaporator first, or it goes over the heater core first, depends on how the vehicle's set up, but it's going to have this door that's going to blend the air going through it. So if I go just over the evaporator and have that blend door all the way to cool, it's going to blow just cold air through. If I move it all the way to hot, it's going to come through. It's going to still go over the evaporator, but then it goes over the heater core to heat it up. And in that case, it is going to blow warm air. Now, don't think it's just going to be blowing cold air, because if I'm in the winter, my air conditioner is not going to be on. But if you think about it, in the winter, and I'm on defrost, what happens? Have you noticed what happens in the winter when you have it on defrost? And even if it's full blast heat, the AC compressor is still going to cycle. Now, why does it do that? There's another nice benefit to the evaporator, other than sending out cold air, is it's going to remove moisture from the air as well. So air conditioners, they just kind of remove moisture from the air as a consequence of how they work. So by doing so, if I'm on defrost, it is going to remove the moisture so my windows don't fog up. So that's a good consequence of that. So yes, it's still going to run over the evaporator and the AC will still work in the winter. And then if I put it on kind of a medium blend, my cold air is going to come over here. My warm air is going to come over here. They're going to mix and we get a medium warmish air. Now, as far as the mode doors, we have a couple mode doors here. We got one that goes between vent, dash, and defrost, and then likewise. So if it comes down here, if I got it on floor, it's going to go down to the floor, of course. If I close that and I have it set to defrost only, it's going to go to defrost. I could also have a half and half where it's defrost and floor if this is a kind of like a 50-50 thing going on there. And then I can also have vent and dash. I could have dash and floor, or I can have full dash like that. So depending on where these mode doors are in space, it's going to put the air where it needs to go. Now, vehicles with dual zone climate control, they're going to be a little bit more complicated, but they're going to still share an evaporator and a heater core. And people think, well, how in the world do they do that? Well, they got a lot more doors on there. So we got a recirc and vent door. We got a couple of doors there, and then we got a couple doors. So those will open and close depending on what side needs what. They can variably open or close depending on who needs what. And then we can also change the temperature based on who needs what, because, you know, if I'm riding in the car with my wife and I got dual zone climate control, I'll have it on like 68, she'll have it on like 85, and it'll still work, right? She can stay warm on her side, I can stay relatively cooler on my side. You know, kind of one overcomes the other eventually, but at least what's blowing on your face. So we got a lot of actuators in there. We can have actuator problems. So in this case, we got a blend door actuator that's having an issue. It's not allowing it out the vent there. It's coming out cold. It's coming out hot over there. So there's a good one. There's a bad one. And then also on these, we often need either to test them by using an actuator test, or we can use a recalibration after the fact to test it as well. So after I'm done with replacing the actuator, I might have to do a relearn, reset, where it's going to go and it's going to learn the distance of travel and go. Now, oftentimes I can have an issue there as well. We can see this, we got a broken part right there, and that's where it would ride on this smaller reduction gear here. So we have a gear reduction in here. Going to be depending on you know, how it breaks. They're all made of plastic, and if one of the doors gets jammed, it can snap a couple teeth right off with that. So you see we got a worm gear there, we got a gear reduction there, and we got a broken gear there. So if it stops on that broken part, it's not going to work. So always take a look inside, or just run the actuator test and make sure the actuator is free of travel, running back and forth. Things can get stuck in there, jammed in there. You see some weird stuff. I know you've seen it too, or like some random pencil just gets stuck in there for some reason because it's under the dash or fell out of the glove box or what have you, and you got wedged in underneath. Seen a lot of weird stuff, especially with blower motors. Animals like to make nests in blower motors, so that can cause a whole host of issues. So let's go live on the tool though and see a couple things that we might be able to see. I'm going to go through a couple different vehicles here. We'll start with that Ford Focus we looked at, had the 1234YF in it. So a couple things we can see. I'm going to go on the scanner side first. And sometimes we can go on the engine, and that'll give us some stuff. So let's see what we have in our like functional tests. So maybe it's an output control. We've got the AC compressor cycling switch. Fan control, high speed, low speed. That could be the outside fan, but the outside fan also affects the condenser. Grill shutters, which also affect the condenser. We can open and close the grill shutters out there. So there's a few different tests that we can do like that. We can also go see if there's any special functions. Doesn't look like on that. That'd probably be more in the HVAC module. We can go to data as well. We may have some data on some vehicles. It may have separate relay switches charging an AC data in this case, or it can be under just the engine management data. So if we go into the AC data, cooling fan, let's see, grill shutters again, variable fan duty cycle, that could affect it. Generator, not really. AC pressure sensor voltage, AC compressor command, on or off. We can see a couple different things. AC clutch output, AC pressure in PSI. So we can actually see that as a PID on some vehicles, not every vehicle. We can see it as a pit on some vehicles. So you actually do some of your diagnosis from the driver's seat if that's way off. You can see that as well. Let's go into the actual HVAC module down here. And we can see some functional tests there. So we have some output controls there. So air mode actuators, going to change the mode door, blower motor speed, high, medium, low, left blend door position, left blend door position percentage. See that. Data display. It's going to show me all the HVAC related data for that module. So different servos, blower motor speeds, and frost door positions, discharge air temperature, right? So that's going to have a in the actual vent, it's going to have a temperature sensor. Floor temperatures. So this one has quite a few different temperature sensors in the inside the ducts as well. Supply voltages, recirc switches, etc. So we can actually use the PIDs to diagnose maybe some electrical problems with the system. Now, how about guided component tests? Because on a lot of vehicles, we do have guided component tests available for vehicles that have, or for the tools that have the guided component test function. So HVAC, AC clutch relay, we can go in and test that. Right, so AC compressor clutch is engaged when the PCM supply is grounded on the AC compressor relay. Activation of AC compressor relay will supply battery voltage to compressor clutch field coils. It's in the battery junction box. We'd want to test that. Check the relay that way. It's going to tell us how to do it. And we can do a resistance test or a DC voltage test. It's going to show us what the relay looks like there, what the pinout is. Compressor clutch itself. We can go in and test that. 12-volt electromagnet, energized that engages compressor clutch to the drive valve pulley. Do a resistance or a voltage test there, and a blower motor relay on that side, so the blower motor itself. So automatic climate control system, the blower relay receives battery voltage from the battery junction box based off the driver's command and blower output. So that's just a few examples of things you might see there. Let's check different vehicle. Let's do a Prius. I'm running a little short on time here. So we'll do a hybrid vehicle. On the hybrid vehicle, once again, we might see some stuff in the engine, but it's probably going to be more in the, there's a lot of actuator tests you can do. So cooling fan, once again. Let's see. Mainly that's going to be it, because I think that most of the other stuff's going to be controlled by the other module. Yeah, so not really a lot in there. There's a lot of stuff you can control, but not necessarily related to this. Routine tests. Nope. Compression tests and such. No special functions, I don't think. Yeah, you wouldn't need any of that in the engine necessarily. You'd probably find it more in the HVAC. Heating and air conditioning. Actuator tests. So air mix, heater levels, radiator electric fan, water pump on and off, compressor target speed, system tests, servo motor initialization. So if I replace any of the air conditioning servo motors, so that's the blend door actuators, I'm going to initialize those. Customized settings. So there's a lot of different things I can change in here. So these would be programmable different changes. So for example, compressor in the defrost mode. So normal or link it to the defrost mode. Let's see, air purifier, what's that? Turns the air purifier on and off with the blowers off. If there's no air purifier function, it's not going to be available. That makes sense. Foot air and face mode. So if it's selected, an additional amount of air will blow in the foot area. Selecting off will cancel the additional airflow. So that just changes where it is. So there's a lot of different things you can change in here, and a lot of things you may be able to use in order to go through and diagnose something. Ambient temperature shift. So it's going to change it plus or minus 3 degrees Celsius. Shifted ambient temperature against the displayed ambient temperature. So if you need to calibrate that, do that as well. All right, and then let's look at a guided component test for this. So let's say it's that one. And there's an HVAC system in there. So blend door, compressor, evaporator temperature sensor, AC pressure sensors. You can go in there and get different things on that. Blower motor sun load sensor as well. Go in there, it's going to give you your different pinouts and such. Could be also part of the automatic light control system, so you could have a separate failure there related to that. So a lot of different things that we can test, a lot of different data that we can get. Just know that in the example for like the scanner, sometimes the body control module, sometimes it's the HVAC control module, sometimes it's the engine control module. So you might need to look in different places to try and find that stuff as well. Also remember, we have critical charge vehicles out there. You don't want to mix oils, you don't want to mix refrigerants. 1234 versus 134. It's going to be fairly close on pressures, but you can find that online. Like I said, MACS. Look that up. It's a Mobile Air Conditioning Society, I believe is what it is. They have a good PDF that you can download. It's going to help you with gauges and temperature versus output and so on. So a lot of good resources out there. I only have so much time, a little over, but that's okay. So that is air conditioning for this week. With that, let's talk about next week. Next week, we are continuing on our OEM-specific training series that we've been doing, and next week it is on Honda. So we are going to talk about a few different Honda vehicles, what makes Honda unique, a couple different ways that they operate that are different than other vehicles in there. So different things we're going to talk about. We've been talking about stuff like this all year, so it's going to be that same type of format, just on Honda vehicles. So hopefully you can join me for that. Same time, same place, 6 to 9 Eastern. If you want to join on Zoom, go to snapon.com/OT. If you want to join on YouTube, the 6 p.m. class goes to YouTube, youtube.com/Snap-on Diagnostics. Make sure you like and subscribe and all those good things over there. 9 p.m. Eastern class goes live to my Facebook page. So it's facebook.com/Snap-on Jason, all one word, no dash, and Snap-on. If you want to see any of the other episodes in this series, anywhere from ADOS to our OEM specific training and more, there's 89 different episodes so far. I actually got to update this slide, but it's all available on YouTube 24 hours a day for free whenever you need it. If you want to scan that QR code, it'll actually bring you to the page and subscribe you automatically. So that's a big help there. So you can just scan that QR code and it'll get you there. Like I said, it's all for free, readily available, all about half hour, 40 minutes, depending on questions. Speaking of questions, I'll get to those in a second. I see we got a few. If you join late on Zoom and you're not sure how to ask a question, and you do have a question, just find the Q&A button. It's going to be somewhere on your screen, wherever your Zoom controls are. Type in your question there. On YouTube, just enter it into the chat. Before I get to that, though, I also want to mention my buddy Keith, who also does free training for diagnostics. His is specific to scan tools, though. So on Wednesday is on Zeus and Zeus Plus, and on Thursday it's on Apollo and Triton tools. One time a night, 7:30 Eastern, 6:30 Central, 4:30 Pacific. It's kind of designed to have the tool sitting in front of you, so he goes along on his screen and does stuff, so you can watch things on his screen. You watch what happens on his screen, and you can duplicate it on your screen. So definitely check that out, snapon.com/OT. If you want to go join up on there. That is Zoom only, so it's just kind of more of a, you can ask questions and type of thing. So definitely check that out. Q&A now. I see Tom just chimed in on YouTube. Thank you, Tom, for correcting me. It's Mobile Air Climate Systems Associates. So there are a lot of good resources on their website to check that out for sure. I know I taught some classes there. We did some lab scope classes there, and I think we might be doing some again here in the fall meeting. Sure. But yeah, definitely check them out for more information. Let's check on Zoom for the questions. Does R1234YF use variable style compressors? Yeah, it's going to depend on the vehicle. A lot of the newer vehicles are going to have variable style compressors. So by default, a lot of the newer vehicles also use 1234YF. There are some compressors, variable compressors, that use 134 as well. So yes, 1234s will use variable style compressors. They'll also use traditional compressors. Just kind of depends. Let's see. Martin says, if anyone doing a top-off charge of 1234YF, I've always preferred a complete recovery and recharge to know the exact amounts, but I know some people would do a top-off. Yeah, I would side with you. So I would not want to do just a top-off, especially on 1234, because it's usually critical charge. So if it is a critical charge system and I top it off a little too much, then it's going to be overcharged and it's not going to work. So always best to do a full evac and recharge with those systems. In what cases do techs need to inject oil into the AC compressor? So anytime you change the compressor, you don't necessarily know if it came with oil in it. Anytime you do anything in the system when you vacuum it down, you're going to want to see how much oil you remove from the system. And then you want to at least put that much oil back in the system when you remove it. So usually most AC systems or machines that I've used, they have a way that you can see, gauge how much oil you remove from it when you evac it. So that's how much how you know how to inject that much in the system. Can you do a retrofit from 1234 back to 134? I don't think that would be recommended. I'm pretty sure that you can go the other way from 134 and retrofit it to 1234YF, but I don't think you can go back. I don't think that would be recommended to go back. So 1234 up like we used to do our R12 to 134 retrofits. Pretty sure those are available out in the wild as well to go from 134 to 1234, but I don't think, like I said, it's advisable to go back. Thank you for your question, Pedro. All right, on YouTube. MHB3 says, finally made a live one. Homesick. Well, hopefully you were able to, well, unfortunately you're sick, but luckily you were able to watch a live one. Maybe I can be like your Price is Right, right? We just used to stay home from school and watch The Price is Right and eat toast on the couch when we were sick. I remember that when I was a kid. So hopefully maybe I'm like your Bob Barker. I don't know. It's just, hello, Nick from London. Thank you for tuning in, even though it's super duper late. And he says, thank you very much for providing this free training. Thank you very much for attending, as always. Tommy's saying hi from Houston, Texas. Welcome. SCS or SC Spider-Man says, dual AC machine, Snap-on dual AC machine that they have shows a hybrid selection on their machine. So there you go. Very well. I'm not sure how I'm going to be honest with you. I haven't used our new machines very much at all. Really haven't gotten into them. I've sold a few, but haven't really gotten deep into what they can do. So I'm not sure how you inject the oil with that. Maybe I'm sure you would do it under vacuum, but I'm not sure if this is a separate machine or if it goes in with the machine itself. Like I said, not all spooled up on that because it's technically not diagnostics equipment, so we don't really get any training on it. So yeah, I suppose that's totally possible. You can do hybrid vehicles with that as well. But I just know we do have that dual machine that is available for the 134 and the 1234, and you don't want to mix refrigerants. You don't want to mix oils. Nick says, can't wait till next week for the next class on Hondas. The Winton 29 says, hello, welcome. Thank you for joining, as always. TJ's asking, I probably won't be able to answer it here, but maybe somebody has an answer. What's the most common problem with a single zone system, but warm on driver, cold on passenger side? Hot and cold actuator does not change anything. The 2013 Camaro. So seems like maybe you might have an actuator problem. You might want to run the tests. Might have the tests available to actuate the actuators, so to say, and see if one of them fails that actuator test. That might be something you want to do. Okay, so let's see. JLE Lobo says, hi, thank you for the session. Claude says, good information. Tom Gebby, going to help me out a little bit here, give me a little bit more information so I'm not speaking out of turn. Any hybrid certified machine cannot have automatic oil injection, must manually inject. So there you go. So you can do the refrigerant on the hybrid vehicles, but you have to manually inject it with the manual oil injector. So there's my answer. So you can't do it with the machine, and that's a good way to keep the oil separate. Makes sense to me. And Spider-Man says oil injection manual only on the Snap-on Dual. So there you go. There's my answer. Between the two of you, thank you for schooling me up a little bit. Like I said, I don't have a ton of experience with those particular machines. Let's see. And Martin says, I talked about vacuum very little, but how long do you recommend to vacuum down a system for? On the automated machines, they're going to vacuum for however long they suggest a vacuum. I know it was usually at least a half an hour when we would do them, at least because like we would use an automated machine, right? So it's not a specific vehicle. It's going to pull down the vacuum. It's going to pull down. Then it's going to check for leaks under vacuum as well. So you want to make sure it can hold a vacuum. So I'd say at least 30 minutes in my mind. Could be specs could be different. Depending on the vehicle, depending on the size of the system. But in my mind, I would do a minimum of half an hour myself. That's just me. Your mileage may vary. Don't always trust the guy on TV. Anywho. All right. So that is questions. Looks like we had a lot of good ones tonight. And I learned a little things about how our machines operate, which I probably should know a little bit better, honestly, but can't learn it all the time, right? So All right, so it sounds like we're through. Oh, we got another one here on the Zoom. Oh, thank you, Martin. You're very welcome. So Mr. Chicken Spit asks, how do I find leaks in an AC system? There are ways to do it. I know we always used to use that little sniffer machine on there, just to see if we found the refrigerant leaking out somewhere. Oftentimes you can find, we would inject oil with dye in it. Not sure if that's necessarily the best thing anymore, but I know it used to be the way we do it on the 134 systems. Put dye in there and use UV light. I know I've seen a lot of videos actually popping up on YouTube lately with people showing easy ways to check for leaks. So there's many different ways out there, kind of beyond the scope of this particular class, but I am taking that as a suggestion for the next time I do an AC class. We'll try and do a section on how to find the leaks on there as well. So kind of outside the scope of this. All right, with that, I think that's everybody. So I'll get my slides moving and we'll get to thank you. Thank you very much for taking a little bit of time out of your busy day to spend a little bit of time with me. Oh, John says soapy water in a spray bottle. Hey, works for tires. It can work for AC, right? You got pressure coming out, soapy water, find out where it bubbles. Perfect. Sounds good to me. That's a very inexpensive way to do it too. All right, so thank you very much for taking a little bit of time out of your day, spending a little bit of time with me. Hopefully we picked up a few little tips and tricks and nuggets on air conditioning. I know I certainly did too. It's always good when you can learn something when you're trying to teach a class and trying to learn something at the same time. It's always a wonderful thing. So I appreciate everybody chiming in tonight. Hopefully you can join me for next week for OEM specific training on Honda. With that, enjoy your rest of your week. Enjoy your weekend. Have a good night. Take care.